Okay, let's finish this off strong and let's get back to it. There's one thing I wanted to check out first though. Let's see. I'm going to put the whiteboard. I'm going to use this whiteboard feature, or try to. Okay. Okay, I want to try this whiteboard feature. I want to see if it records. Last semester when we tried using this, unfortunately, it didn't record it, and so like when I did the recording of the lesson, and so what I did was I did my own recordings of them at another time and then posted those separately. So I'm hoping that it records it. So okay. So I'm going to see if I draw on here. Handwriting is even worse on this than in person. Okay, so that's all I'm going to do. I'm just going to say this is a test, and we'll see if that works. Okay, so how do we get out of here? Okay, so I want to go back. I want to share. Okay, so that's the whiteboard. Let's see if that recorded. All right. But what I want to do is I want to talk now about numerical data types, right? Okay. So I skipped over the name conventions. That I will talk about this numerical data types because it is important. All right. Primarily, like I said, the computer talks in ones and zeros, right? And so if we have 8 bits for like a byte, for example, we can represent the values from -128 to 127. Now, when you take your digital systems class, you'll understand all about why this is the way it is, okay? But this is the different data types. So we have byte, short, int, long are all integer data types. So if we cannot fit it in, what is that? 21 billion, yeah, 21 billion, negative 21 billion to positive 21 billion, we can use a long data type that will be much more, okay? So it's 64 bits instead of 32. We have 2 decimal type numbers. So this is all integer, so byte, short, int, long. Char is also an integer data type, just for the record. Okay, float and double are decimal style, so we can represent fractions of a number, right? And there's ways, and again, your digital systems class, you'll learn about how these are all represented, okay? But for here, double is used more frequently than float in terms of programming in Java. It's just easier that way. So double will be, the reason why it's called a double, it's a double float. It's a double size float. So it's a 64-bit floating point number instead of a 32-bit floating point number. Okay. So these are some of those data types. I can put an integer value into a double number, right? I can put 3 and into a double number, it becomes 3.0, right? I can't do the reverse automatically, and we'll see that in a couple of slides. Okay. So how we read from the keyboard, we can read all these different types: int, long, float, double, byte, short. Mostly you're going to use int. Mostly you're going to use int for integer and double for decimal numbers. That's just mostly how it's going to be. Okay. All right. Some of the operators you need to be familiar with. The simple ones here: plus for addition, minus a dash for subtraction, star or asterisk for multiplication, slash for division of 2 numbers, 1 divided by 2, right? And then the remainder operator. The remainder operator and the integer division go hand in hand, right? So this is a really interesting thing that we can do in computer programming, Okay, we talked about this a moment ago. So when I do 5 divided by 2, gives me an integer value of 2. All right. If I do 5.0 divided by 2, it gives me a double value, 2.5. Okay. The remainder operator, this would be a good time. Let's see if the whiteboard would work. Let's see. This would be a good, because this, you guys know division, so I'm going to show. So if we did, for example, here we go. Come on up. All right, so can I delete that? No, I guess not. I don't want that. So if I were to take, where are you? Let me just move that off. I don't want that. All right. If I were to take, for example, 10, and I believe this is right, you do it like this, right? Divided by, what, like 3. Is this right? I don't know the format in Turkish classes very well. Is this coming up for everybody? 10 divided by 3? Or is it's kind of lagging for me? Well, that's not good. Okay. All right, so if you were looking at my screen right now. Oh, is that what it is? Is it the other way around? Okay. Ah, thank you, thank you. So some of you can see it. Okay, see, All right. Okay. I need to switch the numbers up. Okay. So what we'll do is I'll just explain it. So imagine this was switched over because for some reason this is not. I need to erase this. Yeah, I don't have a lot of practice with using this whiteboard app. And I don't want to learn it if it's not going to be useful anyway. So, okay, so this is what you're saying it needs to be. It needs to be like 3 and 10. So this would be 10 divided by 3, right? Okay. So then, does the answer go down below the 3? Is that right? Yep. So, right, but it would be, we would have 3, right? And 3 times 3 is 9, and we would be left with a remainder of 1, right? I think this is right. Okay. So if we were doing this using integer division, okay, 10 divided by 3 would give us 3. So if we were doing this in a computer program in Java and we did 10 integer divided by 3 integer, we would get 3. Okay. The remainder operator tells us this part right there. Okay. 1. Right. So 10 remainder 3 says when I divide 10 by 3, what remainder do I get? Okay, so if I were to do 10 remainder, which is the percent sign, the percent operator, 10 remainder 3, I would be left with 1 would be my. Okay, so I hope that's clear to you guys. So let's go back to the slides so you can see what I'm talking about. There we go. All right. So when we do 5 integer divided by 2 integer, we get an integer value 2. When we do 5 remainder 2, we get 1. What's that?
Yeah.
Oh, see, I thought there was a question. Okay. When we do 5 remainder 2, we get, when 5 divides by 2, we get 2 with a remainder of 1, right? So that's where this 1 comes from. It's the remainder when we divide this by this. Okay, 5 divided by 2 would give me 2 with a remainder of 1. Okay, think back to division back before you knew about decimals and all that stuff like that. Okay, all right. Remainder operator is a very, very powerful, useful thing for if we want to do a cycle like in a day of the week where there's only 7 days in the week, or minutes remaining. There's an example of that for how many minutes to be charged if you're talking on the phone, that kind of thing, right? Actually, that'll show up. Just a heads up, that'll be a quiz question on an exam question. Okay. All right. Let's see. Like I said, exponent is a method. It's not an operator. Some other languages have exponent as an operator, which can be useful. Java does not give us that. Okay. Let me go into where was it? This one here. Okay. So another useful tool is if we want to assign and add at the same time, or we want to assign and subtract at the same time. So we can do that in Java. So I plus equals 8 would be the same as saying I equals I plus 8. Now, sometimes some students have a hard time with this because they'll equal I plus 8. That's not possible. That's not mathematically possible. What you have to remember is this equals sign is not saying those things are equal to each other. That is an assignment operator. That's saying take what's in I, take what's in my container called I, add 8 to it, so make it whatever it was plus 8, right? And then take that new value and assign it to the container I, right? So if I were 3, for example, we take 3, we add 8 to it, we get 11, we put that into I, okay? The key to remember here is when this happens, just this part over here on the right-hand side of the equal line, I doesn't change when it's calculated, okay? When I plus 8 is calculated, I does not change. It's only once this equal sign, once this assignment operator is performed that the value in I changes. We could have put anything on the other side of this. If we had said J equals I plus 8, J would get the value of I plus 8. I would not change its value. It's only because we put I on this side of the equal sign, on this side of the assignment operator, that the value in I is able to change. Okay, so but this is a shorthand way to do that. If we said, okay, I want to take the value and just add 8 to it, I can do it that way with this, what's called an augmented assignment operator. Okay, sometimes we want to do like I plus equals 1. That happens a lot, to just increase by 1, decrease by 1 over and over again, right? That it's very useful in loops when we start processing through arrays, that kind of stuff. So we can do that with the plus plus operator. So basically plus plus variable is basically like saying variable equals variable plus 1. Okay. The difference, there is a difference between putting the plus plus first and putting the plus plus after, or the 2 minuses, same thing. If the plus plus is done first, it's like take this, add 1 to it, and the result is what's used as the value of this expression. So for example, over here, assume I starts out as 1. We add 1 to I. We get the new value of I, which is 2. We use that as an assignment operator to j, and j gets the value of 2. Okay. Post increment, the plus plus after, we use the old value of the variable as the result of this expression. So I plus plus, if we assume I was 1, after this expression is done, I gets the value of 2, but we use the old value of I to assign to j. So now j is 1, I is 2. Okay. For the most part, this is not something that's all that important to know. In terms of, it's not very frequent that we worry about the value of the old value of I versus the new value of I and stuff like that. However, it is something that you should know because sometimes it does come up. Okay, sometimes it does. It is, and it makes for good quiz and exam questions. So make sure you keep a note of that. All right. So, okay. So here's some examples of increment decrement. Okay, one thing I wanted to talk about too was the whole numeric type conversion. Remember that byte and long are 2 integer types. Double is a decimal type. Now, when we go to put, like we can try to put something of one type into another. Some of them are done automatically and some of them are not. Okay, so when conversion rules have to do with when we are doing like addition, multiplication, some other type of operation on 2 values, and what is the result going to be? Okay, so if one of the operands is a double, the other one is converted into a double and we get a double output. So 5.0 divided by 2, the 2 integer is converted into a double, 2.0, and the result is whatever 5.0 divided by 2.0 would be. Okay? So we would get 2.5. Same thing with the float. Okay, otherwise if neither is a double, if one is a float, the other is converted into a float, and again, floating point operation is done. Okay, and then the same thing with long and then int. Okay. All right, so why is this important? Because just like we saw earlier with integer division, you might do 5 over 2. So you might do 5 divided by 2 and think that I'm going to get 2.5. But this is not a double, it's not a float, it's not a long, it's an int, so it's going to be an integer divided by an integer, right? And then the result will be an integer value. That's the key. Whatever these 2 types are, the result is going to be the same type. Okay, so if we say, okay, fine, I'll do this. Right? Now, this is a double, so what happened? The operand is a double, the other is converted. So then this gets converted into a double, and now I'm able to do 5.0 divided by 2.0. It's going to result in a double type output. Okay? All right. Sometimes we can do implicit casting, so what's called type widening. So if I take an integer type value and assign it to a double variable, Java says, no problem. What I'm going to do is I'm going to take this integer value of 3, I'm going to cast it into its double representation, 3.0, and I'm going to assign that to my double variable. Okay. The problem is that Java doesn't do things in reverse automatically. So even though you and I could look at this 3.0 and say, well, that's a whole number. I should be able to put that into an integer variable. Java would give you an error when you tried to do this. So what we have to do is we have to explicitly cast. We have to say, I want to take this and I want to make it into an integer, and I want to put it into an integer variable. Same thing with this. I can take this, I want to convert it into an integer variable, and I want to put it into an convert it into an integer value and put it into an integer variable. The thing is, if we do this, the 0.9 is lost because it is a partial, it's a part of an integer, right? It's not a whole number. So we lose the 0.9 when we do that. So what's wrong here? What's going to happen? Think about it. Say your answers in the chat whenever you realize what's going on. Okay, why is this? What's the problem here? Okay, let's see. I won't go through that. I would encourage you to look through the software development process slides here. I included them because this is a topic very important to me that I think is going to save you a lot of time in programming if you're able to understand that coding is just one part of the software development process. It's down here, it's this implementation. Coding is just this one part of the whole software development process. There's a whole lot of stuff that goes into it, a whole lot of stuff that comes after. And if we do this well, then things are a lot smoother. Okay, I won't go into all this though, but I do want you to know some common errors, some common problems that we'll do, okay, that we will encounter when writing code. One is undeclared or uninitialized variables, okay? Now, Java is case sensitive. What that means is interest rate with a capital R and interest rate with a lowercase r are not the same variable. Java will say, hey, you're trying to use this variable, but you never declared it. Okay, you never created a variable called interest rate with a lowercase r. So therefore, this is a compiler error because you're trying to use a variable that does not exist. Okay, so that's a common error, especially also if you are someone who maybe has some experience with a language like Python. What sometimes happens is we'll do this, and we'll say, here, I want to have a variable called interest rate, and I want to set it to 0.05. The problem was we didn't declare it. We initialized it. We didn't declare it. Java requires that we tell the variable what type of variable it is. Okay, Python does not require that. Other languages don't require that. Okay. All right. Integer overflow. Remember that inside of an int, right, we can only have a certain size value. It can only have certain many bits, so it can only be a certain size. If we try to add one to it, what's going to happen is we're going to have what's called an integer overflow. And because of the way binary is represented, this value will actually be a huge negative value. Okay. I'm sure that you would not like it if you had this much money in the bank, you added some money to it, and suddenly you had a huge debt, right? I'm sure you would not like that, right? And I don't think many bank customers would. Okay, so there's a common error that if we're going to have something this size, we need to make it a long instead of an int. Okay, rounding errors. So double, because of the way that a double is done, sometimes this will not be the same as this. Okay, we can look at an example of that in just a moment. In fact, it's kind of an important thing that sometimes we think, oh, I'll just subtract 0.1, 1, 2, 3, 4, 5 times, and it'll be the same as if I subtracted 0.5. This is actually not going to be the same as this, as we'll see in a moment. Expecting double division when we actually have two integer numbers like this can be a common error. We do that quite frequently. We expect number 1 plus number 2 divided by 2. We expect this to be the average, and we end up with integer division instead. Okay, simple fix: make some part of it a double, and then the other side will be converted to a double, and We get the average that we expected. Okay. One common pitfall, this isn't an error because nothing's going to be wrong about this, but we will sometimes create 2 or more input objects when we don't have to, right? What happens is when we do this through system.in, we can get an extent. We don't have to create a new scanner. We don't have to create a new input object to get a double value. We can just use the old one again. It's just a constant stream of the input. Okay. All right. So there seems to be a question of some kind. Okay. Okay. I'll try to slow down. Thank you for bringing that up. Thank you for pointing that out. I did want to just kind of go through those slides pretty quickly because we needed to be done with chapter 2 by the end of the day, by the end of this lecture. And I did want to save some time for some examples. I also know that I can oftentimes speak quickly, being that English is my native language. Please do not hesitate to let me know that. Okay, if I am speaking too quickly to be understood, if I'm going through things too quickly, make sure you let me know. Okay, thank you both to Hakan and Baran for bringing that up. Thank you guys so much. All right, so I'll try to slow down. All right. Okay, so what I would suggest, Hakan, is go back over the slides again. You have access to them through the SharePoint folder. If you still have questions, make sure you let me know, okay? But I do want to go through some examples. We don't have a lot of time left today, unfortunately, so I do want to go through some examples before we call it a day. All right, so unfortunately, I won't be able to go back over the slides here, but if you find that you have some questions, let me know, and maybe we can use some time at the beginning of next week's lecture, or maybe Taha Hoja can go over them in the lab. All right. Okay. So what I'm going to do is I'm going to switch over to JGrasp, right, and we are going to look at some examples. All right. Let's see. So we have the compute area. We already looked at that one. Compute area with console input. I do want that one. Average. Okay. And let's do this one. We already did that. Okay. So we want to compute the area of a circle, but instead of hard coding a value in for the radius, we want to get that information from the user. Okay. So what we can do is, instead of hard coding the radius value here like 20, right? What we can do is we can create this scanner object, and again we can call it whatever we want. Input is as good a word as any. And we say, okay, create a scanner object and use the system input to give the value. Okay. Now what's going to happen is the input is going to wait at this point, this next double. It's going to wait until the user enters some information, okay, and then hits enter. And what it's going to do is it's going to read in the characters that the user enters, and it's going to try to convert what they enter into a decimal number, into a double value. Okay. And then when it gets that double value, it's going to assign that value to the radius variable, and then we will use that for the what's it called, as the calculation for the area. Okay, so we compile this. compile this. Wait. Come on. Okay. And then when we run, maybe I should have debugged actually, but that's fine. Okay. What happened was we created the scanner object, and now we are at this line waiting on the user to enter a value. So if I said 5.0, for example, okay. So now when I enter 5.0, it's going to tell me the area for the circle of radius 5 is 78 and some change, right? Now I don't have to recompile it. I can just rerun it again. And enter a different value for the radius. Right? So the area for the circle with radius 10 is this. So then what happens if I said, okay, I want to have a radius of 20. Okay. So think about what will happen. Oh, wow, that's weird. An exception happened, input mismatch. Huh. The reason why is what happens is the scanner goes through character by character looking for something that fits this type. Okay. And when it finds something that is this type, followed by a white space character, it converts it into this, into the double value. Okay. So what I'm going to do is I'm going to show you, I don't think this is going to come up without me. I think so. Yeah, I didn't think it was going to work. Okay. Actually, it's gonna. Well, let me finish this off. I want you to see this thing called the canvas. It's something that JGraphs and a couple other IDEs allow. Yep, good, actually, correct. Those of you stating things there are good. So what I want to do is I want to share just the whole desktop, right? Because I want you to see this canvas thing that I'm going to be using. Okay. All right. Because I can show you what this looks like. So this is the scanner. This is the input stream. Okay. So this is the input stream that the user is entering through the keyboard. So when I step over that next line, the print line, right, it prints out enter a number for radius, and now it's going to wait, right? Now it's going to wait until I enter some information. So if I say 25.3 is my radius, for example, notice what happens. The stream that comes in through the scanner, through the system.in, is 2, 5. Now this is, you shouldn't think of these as numbers. You should think of these as characters the user has entered on the keyboard. So 2, 5, period, 3. Then these two characters just mean new line. It's because I hit the enter key. This is what happens when you hit the enter key. Okay. Now, what happens is this next double thing, what it did was it read through, notice the position is over here on the new line, it read through and got these characters, converted them into a double number, 25.3, and used that as the radius. Okay. Now why is this important? Because, where's my run? 101. Okay. This is important because that example that I just gave where I tried to type in non-numeric characters, right? What happened was okay, was these were the characters that were put into that stream. It tried to get something that was a double type, and the very first character, it said, that's not, I can't do anything with that. I can't convert a T into a double number, all right? Okay, so what about if we do this? What happens if our user does something like 20.4 or 20.4, like that? Okay. All right. So what's going to happen? All these characters are going to get in there. And then, oh wait, let me hit enter. Okay, it's going to give me the same problem. And the reason why is what's going to happen is it's going to try to read until it gets to a new line. It's going to try to read characters and convert all of this into a decimal number. Okay? And it's not going to be able to, because this is not something that can be converted into a number. Let's look at a couple more examples of some problematic things that we might think, this shouldn't be a problem. 20.3.4. Same problem, right? This is not a number, right? You can't have 2 decimal points in a number. Okay. What about 20.3 space 40? Okay. Now you might think, wait a second, what just happened? But didn't, hey, 20.3 space 40, that's not a number. Why did it accept it? I don't understand what happened. When the next double method is done, or next int, or any of these, right, it's going to read characters until it reaches what's called a white space character. A white space character is anything that if you were to print it on a piece of paper, it would not use any ink. So a space is a white space character. A new line like a return, is a white space character. And when it hits that white space character, what's going to happen? It's going to take everything it's read so far and convert it into my double number. Okay. Notice though the position is here, so there's still some stuff out here in the stream, right? There's still some stuff that's waiting to be read. And this could end up in being a logical error later on. Okay, we'll get into that at another time. Okay, but for now, just know that this was able to work for 20.3, and 40 is just kind of lost, right? The 40, it's like as if the user didn't enter it. Okay, all right. Let's end that. Okay. All right. What time is it? It's 12:10. So, well, compute average is basically kind of the same thing, right? Double input next double. Okay, I do want to use this as an example to show you how this could work, okay? How this could work in a strange way. Okay, so do this. Okay. So enter 3 numbers, 20, 30, 40. Okay. Now notice what happened. The stream is 20 new line, 30 new line, I guess actually 20 new line, 30 new line, 40 new line, right? Okay, so as it starts reading these in, right, it's going to give me these 3 numbers, 20, 30, 40, and give me the average of those, which should be 30, right? Okay, let's rerun it and show. That's not the only way for me to enter numbers, right? I could also do it with a space in between, 20, 30, 40. Okay. So now 20, 30, 40, same thing, right? What happened? It read characters till it got a white space. It read characters till it got a white space. It read characters till it got a white space. And it converted anything up to the white space as a double. Okay. Right. Okay. Let's see. Let me try one more for fun. All right. One or two more for fun. So we're going to enter three numbers. Okay. 20. Enter 30. Enter 40. Enter. Okay. So now notice that where my error happened. My error happened here. So it read 20 and it converted that into a 20 with no problem. Then it tried to read these characters as another double, but there was a problem, right? Okay. There was a problem. This cannot be a number, right? And so it didn't matter. It never got to here. It never got to reading this because it ran out, right? It ran out. The exception happened, the runtime error happened, and then it wasn't even able to read these at all. Okay? So I hope that's clear there. Let's see. Oh, what I want to show you, what I want to go ahead and show you too, is actually I'm going to do this like this. Is sometimes we want to, let's say, do one thing, but we don't realize something of what's going on. Let me just explain it like this. So I want to calculate the average of my first two numbers, and then I want to see what the average is when I include a third number. So what I'm going to do is I'm going to say average let me see actually this isn't a good example for this. Let me get a new example for what I'm trying to teach right now, and I'll bring it to the lecture next week. Because what I'm wanting to show you is that, remember what we saw earlier. What we saw earlier was if we had extra characters, extra things in the stream afterwards, what happened was they kind of got left hanging out there, and that can cause problems for us. That can cause logical errors. It can cause runtime errors. It can cause big problems. So like the example I'm talking about is if I did 1.5, 2.4, 3.6, 4.8, 6.0, like this, right? So if I do this, what's going to happen? It's going to read in 1.5 as number 1. It's going to read in 2.4 as number 2. It's going to read in 3.6 as number 3, and it's going to calculate my average of those three numbers. And this 4.8 and 6.0, it would be tempting to think that that's just lost, that we'll never see that again. It's just extra information the user entered that they'll never see again. But that's not entirely true. They are still sitting here in this stream waiting to be read, waiting for stuff to come, waiting to be used. And there may come a time where we try to read something else in and we want the user to enter new information, but this stuff is still sitting out there clogging up our stream. Okay, so what I'm going to do is I want to leave you hanging a little bit, maybe like a reclam for the next class, right? An advertisement for next week's class. I'm going to show you an example where leaving this stuff in the stream like that can cause problems. Okay, so that's one thing that we need to be careful of, is not to leave stuff in our stream if we don't expect it to be there. Okay, all right, so let me run through this. Let me check and see. All right, let me go and check and see if there are any questions. Alpair, yes, that's right. Any exception that ends the program unexpectedly is what's called a runtime error. Like I said, Java's calling those exceptions. The general term would be a runtime error. Right. It won't be deleted. Remember, because what we'll see, Omer, next week is we're going to see that the characters are still there in the string and in the stream of input characters, and we're going to see what happens with those if we don't expect them to be there, but they're still there. Okay. Unfortunately, Alpair, the whole converting a string like 20, like TWENTY, converting it to 20, the numerical value, that would be probably a problem that people working on artificial intelligence might be able to do. That is something that you and I can look at that and know that, well, 20, it's a word, but it means it's a number. But the computer doesn't understand that. The computer only knows that it's seeing a string of characters. Okay. Are there any other questions that I'm looking back at? Okay, I think I've covered all the questions. All right. So what we'll do is we'll end. So it's if you think of it as a pipe, as like a flow of stuff coming in, like a pipe of maybe like a water pipe or something like that. It's still in there. It's still waiting to come out of the pipe. But because we haven't read it yet, we haven't done like a next double or a next int or a next, just next, which reads a string of characters. All right, because we haven't read them yet, they're still just sitting there in the pipe waiting to be read, waiting to come out into the program. Okay, so they're just kind of hanging out there, waiting to be seen. And what we're going to see is, like I said, let me leave you wondering a little bit, because next week, one of the first things, right, it could. What is more likely, Alpair, what we'll see in my example next week is, instead of reading it as a next double, we may read it as something else and end up with either a runtime error or a logical error as a result. Okay, so, well, like I said, I'll have an example of this for next week, and we'll see how leaving those characters in the stream, leaving input not being read, can cause some problems. Okay. All right. Good questions. Good questions. I'm really glad that you guys are asking questions. I was really nervous that you guys would all be silent and not say anything and not ask questions. Okay. All right. So I will end the recording there. We'll end the meeting. These should be uploaded within the day. And if you want to rewatch them or to re-understand some stuff, then that'll be that. Thank you guys. I'll see you a week from today, and you will have a lab on Tuesday for those of you who are also in the lab course. All right.